little air feet. There's little feet. They've got compressed air tanks inside the set. There's actually a tech person on the set, in a little room in the set, operating the set. Yes? Are you picturing this? And there's this set that weighs 5 tons, and it's now floating on a little film of air. So they turned one on, and they go, here, give it a push. And so I walked up to the set. Okay? Now keep in mind, if I walked out into the parking lot and I tried to push one of those SUVs, I could not move it, and the good reason that I couldn't move it is that it's touching the ground with tires that are designed to grip the ground. And I could not move it because, well, you can't move cars across the ground. It's too much friction, yes? Here was 5 tons of stuff floating on air. I should be able to send it flying, yes? So I walked up to it and I went, and it felt just like that. Honest to God, it felt like a wall. It didn't move hardly at all, right? I'm just sitting there pushing on it. It had this, right? And I laughed because, of course, what did I think they did?
They turned it off.
Yeah, they turned it off and they're laughing at me, right? No, it was on, right? And they go, oh, it is moving, look at it. And I look at the thing and it's going like this. Honest to God, it's like moving 5 centimeters a second. And it keeps moving 5 centimeters a second. It's just moving, right? Because of that great mighty heave-ho, yes? Okay? Yeah, they don't get high school soccer players to push the sets around. They hire, who do they hire? What sport is very good at pushing things? Football players or rugby players, right? They get football players, they just, right? They spend all practice like learning how to push things, right? Okay? And so they get football players to actually move these sets. They get 10 of them, right? And they can move the set pretty fast, right? And they get it off, and then how do you stop it? If 10 football players push for 20 seconds, then you could have 5 push on the other side for 40 seconds, right? Or you could have 20 push for 10 seconds, or you could have 10 push for 20 seconds, or you could just turn off the air, right? It just settles down. It was the weirdest thing, right? There was this thing floating on air, there was no friction, and I couldn't move it just because it had so much inertia. Isn't that weird? That's weird. We don't ordinarily get a chance. I would like air tracks like that weighed 500 pounds. Wouldn't that be fun that we could ride? And they keep cutting it out of my budget. I ask every year, I'm like, I need the big 500 pounds, 20 feet long, right? And they're like Murray, you know. I don't know, we should build one. There we have it. Okay. And then if we can, I bet he's tired of that. I'll just move the camera for him. He's like, move your own darn camera. Okay. There we go. Okay, so this is in short, Lance. In short, this is what Galileo said, was that objects tend to keep doing what they're doing. Okay? If I took a hammer, an MC hammer, I happen to have a hammer right here, and I were to go into space and throw the hammer, it would fly through space, it would rotate. Okay, its rate of rotation would remain unchanged, assuming that it didn't encounter like dust or another planet or the Voyager 2 spacecraft, yes? Okay? I would throw it and it would fly through space forever and ever. Its rate of rotation would not change. The axis of its rotation, the direction that its rotational axis points, would not change. It would stay exactly the same. Okay? The speed with which its center of gravity moves through the air would move in a straight line. The center of gravity would move, or center of mass would move in a straight line. Okay? That speed would remain unchanged. It would move in 1 second exactly the same amount, right down to an atomic diameter forever and ever and ever. It would keep going forever and ever. Isn't that interesting? Now, it's interesting to me that Galileo discovered this idea or came up with this notion that that's the inherent nature of objects. Now, let's think about his other controversial topic, the one that got him into trouble with the earth, with the church. Okay? And this is the notion that the earth rotates. Okay. At the time that Galileo or Copernicus and all these people were saying this stuff, right, they knew the size of the earth. They knew how long it took to rotate. They knew that right now we're going 900 miles that way. Yes? 900 miles an hour is how fast we're heading toward Mount Hood. Now it's moving away from us. Gentlemen, nothing's more exciting than this. Okay? We are going 900 miles an hour that way if the earth is going to go around once every 24 hours. They knew this. Okay? They've known how big the earth was since the time of the Greeks. Okay? So, look around. Are we going 900 miles an hour? No. No, we're not. Okay, that's unbelievably fast, and I can tell you we're not going 900 miles an hour, right? Okay, that's what they said, right? Of course we are, the desks are, the air in this room itself, the ground, the earth, everything is going 900 miles an hour, and apparently has been for 4.5 billion years. That's inertia. That's what it's been doing, and that's what it's going to keep doing. It would take something like Superman, right, to make it go the other way or something like that, and then time would go backwards or something. Isn't that how it works? I think so. I saw that movie. I saw it in a movie. It's got to be true, right? Okay. So yeah, in short, you have to believe that objects will continue doing what they've been doing to believe that the Earth is rotating that fast. Yes? That's amazingly fast, right? So you have to believe in, you have to have the concept of inertia before you can then realize that the Earth rotates, right? Okay. Yeah. Kind of a interesting thing. So,
miles per hour in the opposite direction, would time cease to move?
No. That's Superman, not reality.
No, I know.
It's kind of cool.
I
Kind of a cool idea, right? But here's a cool thing, right? Here's a weird thing. When we launch our satellites, we always launch them in the direction the Earth is rotating. So we always launch them eastward, right? Because the Earth is spinning, we're always spinning toward the east coast, right? No, yes, I do, because the sun rises in the east, right? Okay.
Say something from space, like coming back, don't they kind of like project?
Oh yeah, they gotta. Their velocity relative to the atmosphere, they've got to take that into account.
Like aiming, like,
Yeah.
way ahead of where they're
But
gonna be.
but here's a sad thing, right? To orbit the Earth, you just go fast around the Earth, right?
Yeah.
Okay. If you launch yourself toward the west, you can go 900 miles an hour and not be moving relative to the Earth, right? You can go 900 miles an hour relative to the Earth, and you have no orbital velocity. Yeah, isn't that sad? So that's why we launch in the direction we do. A lot more fuel, right?
Yeah, I know.
You have to put a lot more fuel in your rockets. So that's why we always launch things toward the east.
I mean, relative like to Earth, like where would you be? Like,
Here. I have a globe. Where is my globe? There it is. Voila. Okay. Here is, and this is a tangent worth going on. Here's the Earth. This one has like the USSR on it still. So this is the Earth, pre-breakup of the Soviet Union. Okay. The Earth is rotating this way. Yes. Okay. And we know that because, of course, the east coast of the United States, which is almost worn off, sees the sun first. The sun rises in the east, right? So the sun's here, rises like that, right? Okay. So that's why our launching spots are as close to the equator as we get, right? We launch them from Florida, which is, without like conquering some poor nation, right, is as close to the equator as we can get, right? And still maintain high security, right? So we launch them as far south as we can, and then we also launch them in the direction that it's moving, right? If we launch the other way, if we launch this way, we would be going 900 miles an hour this way relative to the Earth, but sitting still, right? We'd have zero orbital velocity.
that's what I meant by like the more like
Time isn't gonna
the sun
change.
As in, like the sun and where.
Oh yeah.
Earth-
The
that's what I meant,
sun would
like-
never
yeah,
set.
the sun, like, you
Sun would never
like,
set.
Yeah, you
Yeah.
never like exit day.
Yeah. Right. Yeah. There we go. Okay.
Endless day.
So let's hit the right arrow, rate of fall, blah, blah, blah. Moving objects, we already did that. So here are Newton's 3 laws of motion. The first law is, of course, almost entirely Galileo, right? But there it is. An object at rest will remain at rest, an object in motion. So write this down. I'm never going to ask you to memorize it, but there it is. Will remain in motion at a constant speed in a straight line. So that, by the way, means constant velocity. A physicist would know that constant speed, straight line, translates to a velocity, right? Because velocity is speed plus direction, right? But here we're not just talking about like to the right or the left. We're talking about like north versus 5 degrees off north or something like that. And then this just basically says that objects have inertia. And now I have to do all sorts of really stupid demonstrations. Everything and nothing. Okay. Are we ready for this? Okay, my first demonstration. Okay, I'm going to start with less impressive. I'm going to work my way up to more impressive so that at some point there's just going to be like this fever pitch of excitement in the room. Okay? My first demonstration. There are many ways to put pennies in a can. The first way is like that, but the second way is much more fun. You place the penny on top of a card. You have it overhang the can like that. You slide the card so that it's close to the meter stick but not touching it, and then you go snappy. Okay. Now, you can also put 2 pennies in the can